Good morning, everybody. Welcome to the Frosty Drew Observatory and Science Center live stream of the solar eclipse. So we're down here today, Derek and I, at Point Judith. Derek is set up over in the parking lot. I am at the Fisherman's Memorial on the hill, and we are currently waiting for the sun to break over that water line right there. If you notice, take a look at Derek's image right there. Derek has a fabulous view of a solar pillar that we're seeing right now, which is where we're just seeing a lot of light from the sun scattering among some of the clouds and humidity directly above it. And from our point of view, it gives you a really fantastic view of a pillar. I'll probably get it over here as well for you. Now, this morning's eclipse is an annular solar eclipse, which means that it's not total because the moon is too far away from Earth to block the entire sun. So it leaves a ring of the sun around the moon. So from our location in New England, we're not going to experience an annular eclipse. What we'll experience is a partial solar eclipse. But if you remember the eclipse in August 2017, that eclipse maxed out at about 68% during maximum eclipse, 68% eclipse. This eclipse will max out at about 72% during maximum eclipse, which would be around 531. So I'm going to turn things over to Derek and see if he wants to show you the pillar, talk a little bit about his rig, and I'm going to get the telescopes over here tuned into the sun.
All right. How's it going, everybody? Good morning. It's an early one. Normally the astronomers are staying up late. Today, the opposite. So while Scott gets set up, I'm going to talk to you guys a little bit and see if we can come up with anything. I've got a rig over here as well. We'll do a quick tour of that. Sorry, I keep glancing up because I don't want to miss when the sun pops up over the horizon. As you saw in the picture earlier, we do have some clouds on the horizon, but after the first few minutes, we're hoping those will burn off. So we might miss the initial over the horizon, but it should be a pretty good show for about, I think we've got a little over an hour of actual eclipse event. And I spent a little time over the weekend doing some arts and crafts to make a solar filter for my telescope. Really, really simple, but it uses a approved film from one of the manufacturers that you can buy stuff from for astronomy gear online. All right, I'm gonna take the camera off my computer and we'll show you what we've got. Of course, they drop you. So you can see here the telescope that I've got set up. I've actually got two telescopes here. Well, I've got a camera and then a telescope, and sitting on a German equatorial mount. And you can start to see the sun coming up just a little bit there. That pillar's getting a little stronger. And yeah, we'll keep this view while the sun pokes up through the clouds. And then we'll see if Scott's got something here in a little bit. But we are south of the center line of the eclipse. So the people that are going to see the full ring are on that center line. That line runs starting in Canada, through the Canadian Arctic, over to Europe, and then over into northern Russia. It's running across the northern part of planet Earth. We are south of that line, and the eclipse actually started, I don't know, maybe 45, 50 minutes ago, while the sun was still set for us and had not yet risen. But if you were in Europe or further east by quite a bit, maybe like Nova Scotia, you might have seen some more of that eclipse. But we will get to see the maximum eclipse here in about, I don't know, 15 minutes. I think it happens around 5:30. I didn't memorize all of the times to the minute, but just a general idea. You can really see a beautiful sunrise here this morning. I think the sun is up at this point. It's been up for about 5 minutes, just sitting in those clouds. But That's New England, clouds. But you can see above that, once we get a few degrees off the horizon, we should be able to see what we have to work with as far as the eclipse goes. And maybe my camera will focus. It's an old cell phone. Keeping it real simple. So, you want to see where Scott is? Scott's way over there in the distance. Oh, it's not going to focus, is it? No, I don't think it's going to focus. Well, we'll zoom in anyway and see if it figures it out. Scott's on that little hill over there. I'm set up in front of the lighthouse, the Coast Guard station. All right, Scott, you back? Putting his headphones on. You were back, Scott?
I'm back.
All right, hopefully people can hear me through my whole spiel there. But yeah, it looks like the sun's in the clouds there. But we have a nice, beautiful sunrise with the clouds and the color. So we're going to wait a few minutes while things develop. And then I'm going to get my camera set up now that I assume Scott is. And then we'll see where things go.
All right, so we're still waiting for the clouds to clear a little bit. Turn this over this way here. You can see it with my not so great camera on my laptop. So we have our hydrogen alpha telescope and our white light telescope set up over here, tracking the sun. So this moment we definitely have some clouds on the horizon. Now it's important to note that sunrise eclipses in New England are difficult. We've attempted them in the past, and having the expectation that you're going to have clear skies from your location all the way out the atmosphere looking over the horizon to the east is borderline wishful thinking for New England weather. But we do have, it is a beautiful morning out here, and it's actually notably cooler this morning than it has been for the last couple of days, which is nice because when I got here overnight to set up, it was quite warm. So some things about this eclipse today. The only region on Earth that are actually going to experience the annular part of the eclipse is going to be Canada, like northern Canada, and then Greenland and into Siberia. Outside of that region, everyone else is just going to, not even everyone else, just largely the northern hemisphere and Europe and just the East Coast will experience a partial eclipse. Now, today's eclipse began at around right after 4 o'clock this morning. That's when the eclipse actually began. And maximum eclipse will occur at 5:31, which will be just under 72% eclipsed. The eclipse will continue until about 6:30, after which the moon will depart the visible area of the sun. Now, something to think about when we think about eclipses. So you hear a lot that, you know, the sun and the moon, that they appear to be the perfect size, so the moon blocks out the sun just perfectly during an eclipse. But that's not entirely true. And anyone who's experiencing the annular eclipse today would be able to attest to that. What it comes down to is where the moon is in its orbit. So thanks to Johannes Kepler, we realized that there are no perfectly circular orbits. Every orbit has a little bit of a deviation from that perfect circle, including Earth's orbit, including the moon's orbit around Earth. And we end up with a close point and a far point of the moon as it completes its 27.3-day orbital cycle around planet Earth. That far point is called an apogee. The near point is called the perigee. When the moon is at perigee and we have an eclipse, then yes, the moon will obscure the entire visible area of the sun if you're at the right place on Earth when you're in line with that. But when the moon is closer to apogee, as it is today, the moon doesn't fully occult or eclipse the sun, and you see a ring of the solar photosphere around the moon. And that's what's happening today. The lunar apogee for this current cycle happened on the 7th. So we're a couple days past. And you're definitely starting to see some brightening up in the sky up there. I'm going to switch over on my screen real quick to see if I'm starting to get a view. Anything over here?
Yeah, I was trying to get that as well, but I think
with
it's
our
still
filters,
just bright clouds.
With our filters, it's difficult to capture a live view of the sun in this level of clouds.
Here, we'll take you on another field trip. That's what we've developed into. Got a little higher. Bright spot is still within the clouds, though. Bright spot being where the sun is, but it's not actually the sun. It's just the sun lighting up all those clouds. Yeah. There's some lag.
Now, if you guys are at home watching and you can actually see the sun from your location, make sure that you are using safe viewing equipment. You can't look directly at a solar eclipse, especially this kind. All right, Derek, I got it. Let me get the... All right, so I'm going to share my screen, and then I'll try to get the rest of this in view while I'm sharing my screen. That is a very, very nice view. Okay. So here you guys go. I'm going to try to get this a little more centered right here. And then we'll work on all of our exposures and all that while we're looking at it. Look at that. That is a fantastic view right there. That is a beautiful eclipse. I mean, look at that. That's a beautiful view. Now you can see the clouds over that, definitely. But that right there is an eclipse. Now, at this point, if you guys remember the eclipse from back in 2017, you'll realize that the eclipse is much more dramatic than it was back in 2017, when much more of the sun is covered. Now, when we're looking at the sun, the telescope I'm using at the moment, that's giving you this live view, this is a type 2 white light filter that we have on a refracting telescope. And this will give us a false color view of the sun. So in this case, I have it set up to use it's a monochrome camera, so it's just going to be in black and white. Though when we process our data sets out later on, these will actually be, what we'll do is we'll integrate a false color to the images. And it will be a little bit prettier to see. Now, if I get a best view here, this is a little bit larger than I expected.
I'm getting mine dialed in now.
Now, you're going to notice some things about the moon and the sun here. So for those who are not familiar with an eclipse, goes without saying that dark region you see, that black area that's in front of the sun, that's the moon. And the moon has orbited today in between the Earth and the sun. So this happens once every 29.5 days. Now, you noticed before I said 27.3 days. It takes 27.3 days for the moon to complete one full orbit around the Earth. And that's called the sidereal period. But it takes 29.5 days for the moon to complete one full phase cycle. And that's called the synodic period. And that's because we're also orbiting the sun, and the sun plays a very important role in our view of the lunar phases. Now, the big question with that is, how come once every 29.5 days we don't have a solar eclipse happening? And that's because Earth's moon doesn't orbit Earth inclined to Earth's orbital plane, which would be Earth's equator. The moon actually follows the ecliptic, which is the plane of the solar system. And it orbits inclined about 5.1 degrees to the ecliptic. So every synodic cycle, the moon can, during the new moon, because that's when it's in between the Earth and the sun, can pass anywhere from 5.1 degrees below the sun to 5.1 degrees above the sun and in between. But every once in a while, it will pass right along the ecliptic, which passes right into our line of sight with the sun. And this happens about once every twice a year. We see this happen. But it really comes down to where you're on Earth as well. I mean, the moon is small enough where if it's passing like along the bottom of the sun or just below the ecliptic and you're in the southern hemisphere, like Antarctica, then yeah, you'll get an eclipse. But us here up in the north, we'll miss out on it. So now we're starting to, I just got see these here? These are eclipse glasses. This is what you want to be using. So look at this. Now I can see it with my eclipse glasses right now. And it is quite sexy. That is one sexy eclipse. I'm going to tone down some of my exposure here a little bit because we're definitely starting to overexpose it on the screen. There are a couple sunspot groups in view today. And it'd be nice if we can capture some of those in our view. We still have a couple clouds passing around right now. Let me see if I can try to rotate the camera a little bit to get more of the eclipse in our view.
Yeah, despite me doing all this setup the other day to get my focus dialed in, mine is out of focus.
Derek, you're fired.
I know.
I focused my rig on Saturn early this morning, and because I wanted to make sure that I was able to get a view as soon as we can, and then I was going to screw around with the hydrogen alpha telescope in a little bit. Okay, so
all right,
there we go.
If you want to, all right, mine's good to go now. I think.
You got a view? I'll cut out my screen real quick and I'll hand it over to you to show off a wider field. All right.
Well, I don't know how much wider it's going to be, but it's a little bit. Let's see what we've got.
You ready?
A whole tab. Yeah.
All right, it's all you, Derek.
All right, hopefully this works. All right, so you should see
nice.
my control software with an image of the moon in front of the sun, and you can see that crescent of the sun, and it's pretty much in focus. We're gonna go with that for a little bit, and as it gets a little higher, we might try and fix that. But there, we'll center that up. But you can see those bands in front of the sun and moon. Those are the clouds on Earth here, and we can start to see. Let's dial this down a little bit. See if that
I'm just going to note real quick, Derek, that we are currently at maximum eclipse right now.
5:32. Okay.
So cool. This is maximum eclipse.
Worthy of a picture.
There's just something about
definitely getting brighter.
Seeing the eclipse just right over the water like that is very, for me, I feel like it's very different than seeing an eclipse directly up overhead, or not directly overhead, but higher in the sky, like midday, like we did back in August 2017.
Yeah. And it's definitely coming through the clouds now, because I can't even look at my rig without it hurting my eyes.
Do you have your glasses with you, Derek?
They're in the car, because I had the place I picked to set up was a parking lot. And I was like, great, I can just drive out here, set up next to the car, and it'll be real quick. And when I got here, the parking lot was barricaded off, so we had to park on the road and hike my gear in. It wasn't too far, but it meant I only got 2 trips before I had to get started setting up, or this would not have happened in time. So, let's see if we can twiddle that a little more. Looks a little better.
A couple more minutes,
Still
I'll
a
be
little
able to get the hydrogen alpha on it.
Yeah, and the reason Scott has to wait for the hydrogen alpha is because that wavelength of light is very close to the absorption line for water. And, well, clouds are made of water. So in the hydrogen alpha spectrum, it completely blocks out the light because it all gets absorbed by the cloud. And it's really fascinating when you're looking at it through a hydrogen alpha telescope, and a little tiny cloud, just like barely imperceptible, floats in front of the sun, and it almost completely blocks out your view, even though you can stand on the ground and see the sun there just as fine as it was almost no cloud. So pretty interesting.
I'm cranking up the exposure and the gain on the hydrogen alpha right now. See if we can get something there. Maybe. Let's see. I'm going to swing this guy around a little bit and see what we have here.
That'll be cool. Because I think this filter, much like
HA.
Yeah, this filter that I'm using, much like Scott's white light filter, is basically showing you the white light spectrum of the sun. This telescope doesn't have near the focal length that Scott was showing us. So when I was testing this the other day, you could barely make out one of the sunspot groups. But nevertheless, it does have a nice view of our eclipse.
All right, let's
see. It's actually quite pretty with the water in there. I'm going to take a picture and then show you guys. Let's see. I don't have anything that wide other than my phone, so if you can see my little, I'm going to stop presenting real quick and then do the classic hold the phone up to the camera here. Stop presenting. Actually, we'll just go for a field trip. All right. All right. There's the rig. Well, sideways. There's the rig. And then you can see how much brighter that is now. And then you've got the sun reflecting off the water. Looks pretty awesome. It's completely overexposed in the phone camera, so you can't see the actual eclipse in that view, but you can at least get an idea for what the terrain looks like.
All right, so this is the sun in hydrogen alpha right now. Now at the moment, I'm still trying to get some of these. See if we can get any of the. There we go. You can see right now. Just so you got the moon obviously cutting into your view, but then if you look on the sun, the region of the sun there, that's the solar chromosphere we're looking at. I'm trying to get a little bit better focus, and along the chromosphere there, you can see all those magnetic field lines that are in view. So they're kind of mixing in and out with the clouds a little bit. But you'll notice that you have some of these dark regions down in here. These are all part of the magnetic field lines on the sun. And this is one of the great things about hydrogen alpha, is that you can actually get a view of some of you're actually looking at the chromosphere instead of the photosphere of the sun. Now there is still some clouds over it, and that's making it a little harder to get a view. Actually, if you notice right here, you got a nice charged area of magnetic field lines right here. So this could be a region where a sunspot may be forming. Throw my glasses on real quick. Try to get a little bit better focus on that.
I'm going to run to the car real quick and grab my glasses.
Yeah, don't go blind, Derek.
Yeah, don't go blind. It's a good call.
So we do have a little bit of wind this morning too at my location, but we have this eclipse is actually working out really great. If you are at home right now and you have eclipse glasses from back in 2017, grab them, hold them up to the sun like this, you know, like just kind of like just back a little bit so you can't see the sun, and just kind of move them around and see if you could see any light popping through the glasses. If you do, don't use them. If you don't, then put them on and give them a try. And you can get a really good view of the eclipse right now. Now, in the United States, I feel like we kind of get the shaft on eclipses, especially solar eclipses. You know, you hear about them all the time happening in like South America or Australia. But in North America, not so much. Though we are in a period right now where we are getting a few eclipses that are going to be happening. So we have obviously today's eclipse. The next eclipse will be in October 2023. And then in April 2024, we have a fantastic eclipse coming through our region. In Rhode Island, it'll be 98% eclipsed. I mean, to give you an idea, right now we're probably about 69, 70% eclipse at the moment, with maximum eclipse, which occurred about 5:31 at just under 72%. But on the April 2024 eclipse, if you just cruise on out to Western New York or go up to Vermont for the day, you'll be able to see the total eclipse, like totality, you know, corona in the sky, shadow on the ground, that fabulous view that everybody went after in that last eclipse that we had back in 2017. We will definitely get that in our neck of the woods.
And it is April, and it is New England, so
yeah,
keep an eye on the weather.
So I'm gonna take a look at the chat here. What do we got here? The last eclipse, I used 8 pairs of sunglasses to see it. That must have been uncomfortable.
Also not recommended.
4 a.m. to 9 a.m. in Texas. Actually, I believe Texas is going to get, in 2024, Texas will get the total eclipse as well.
Yes, it runs from Texas through like Oklahoma, all the way up through, as you said, New York, and then I think northern Maine, and then into Nova Scotia. But the maximum eclipse for 2024 is actually in Mexico.
Yeah, that's going to be quite a show. I'm excited about that. And I'm going to duck out too on that day. My sister lives right along the total eclipse line and up in upstate New York, and
that's cool.
It's going to go there and avoid everyone else for the day. Someone says
my the road trip I did for the 2017 eclipse. We drove out to Tennessee and then drove back. It was like 30 hours of driving for a 3-minute event.
For those who were at Frosty Drew that day, you probably remember me walking around with my smartphone showing pictures that Derek was sending me in real time from Tennessee. And if you visited Frosty Drew since then, you'll notice that inside the observatory building, we have a panorama mosaic of the eclipse from that period that shows totality. And that was Derek's work that he did in Tennessee. If you haven't seen it, stop in and take a look. It's worth it. So I'm just enjoying the view here. And I got my eclipse glasses, which I keep putting on and taking a look. The eclipse is largely behind me at the moment, but I'm going to turn around so it's in front of me. Well, something to keep in mind too, when using eclipse glasses, put them on before you look at the sun, and then look away before you take them off.
Yeah, and if you have
a lot of people with them.
For the binoculars.
Well, I like it when people put them on and then they're looking at the sun and they take them off real quick and put them back on, take them off and put them back on. Like they're going to see something better without them.
Oh, here goes. There's a plane going towards our eclipse.
Is it going to pass into it?
No, I think it's going to go just over and to the left, at least from my angle. You might have a slightly different angle.
I'm going to catch some data on this real quick here.
Oh yeah, I got to push my intervalometer broke, so I've been. It seems to be my thing with eclipse work is it always has to be manually done. I did the whole 2017 eclipse manually, just every 2 minutes pushing the button.
Nice.
Give me something to do for the day.
Before Derek married his girlfriend, they used to come out to Frosty Drew together for meteor showers, and he would have her sitting right at his camera for the whole night, just hitting that button.
It was technically her camera at the time.
Yeah, we actually
one, right?
we started nicknaming her Intervalometer.
Yeah. I don't know. That's a pretty close approach by that plane. I can't see it in the binoculars with the solar filters on, but they're probably getting a nice show up there off the right side of that aircraft.
Derek, did you want to switch over and show anything?
Yeah, let's go back to the view I've got, and then we'll see if anything develops.
All right, you got it. I'm actually quite happy that the weather was panned out so nicely this morning.
Yeah. So definitely pretty similar view to what Scott showed us, and we can see the moon is moving off the sun. We are almost at that center line of the sun. Well, maybe. So if you drew a line top to bottom on the sun, moving towards that. I forgot to hit record on this, so we'll record for a few minutes. Hopefully it doesn't. Oh, sweet. So never mind. We're not going to record. So let's see. It's worked the other day. This is the classic thing in astronomy with computers. It all works when you test it, but it never works when you really need it to. Yeah, we're just not going to work today. Okay.
All right, I can switch back. I got zoomed out a bit too, so now we have a much more natural looking view of it.
But you can see there's still some clouds going on here. Those bands are not on the sun. Those are clouds here on Earth.
Yeah, right. Don't believe it, huh?
Yeah.
All right, I have a wider field view now. If you, I haven't even seen what you're doing yet. I've been playing with mine.
I just got the same view that I had up before. So it's the only one that I have capturing to the computer.
Oh yeah, nice. That's actually similar to what I got up right now. Awesome. Wow, this is definitely coming along. I'm quite happy that it's panned out so nicely today. Like, I wasn't too sure how this was going to work out.
Yeah, the weather here is phenomenal. It is really nice.
Beautiful.
Uh-oh. Well,
I'm gonna grab 1,000 frames real quick here.
In my haste to set up, I did not bring my computer power supply. So when that dies, I will go run and grab it, and then I'll join you back.
Yeah, I think my battery is my laptop might just make it.
Yeah, mine says 10%, so clearly streaming video kills it pretty quick.
I'm streaming video, but I'm also saturating the USB 3 bus right now.
Oh, that's good. Those cameras will certainly produce some data.
I got 2 of them plugged in right now.
Yeah, you can see the contrail through the binoculars. Actually, this line down here to the bottom right of the moon and the sun there, that's the contrail from the plane that went by.
I can see it with my glasses.
Yeah.
I'm going to switch over real quick and show a wide field of the hydrogen alpha, all right?
All right, sounds good. I'm going to run and grab my power supply while we're doing that.
Cool. All right, so here is a zoomed out version of the eclipse. Now this is much better from a viewpoint of looking online, because this is actually what you would expect to see if you're looking at it with your eclipse glasses. And in this view here, as Derek was saying, you got a lot of this wispiness. These are clouds, you see, but this graininess that you're seeing with these bright spots here, these are the magnetic field lines of the sun. When you're looking at the chromosphere, you're looking at the atmosphere that sits above the photosphere, and the photosphere is kind of what we relate to as the surface of the sun. It's where the energy release from the sun happens, and all of that radiation gets dumped into the chromosphere. But it's plasma, and so plasma is, it's like a hot electrically charged gas, so it's got magnetism, and all the magnetic field lines of the sun's very intense magnetic field, they cause a plasma to flow along inside the chromosphere. Inside that region, you'll have sometimes these magnetic arcs that form where plasma will flow out and then come back down to the photosphere. Sometimes those magnetic arcs will flap open and then slam shut, and they do push a little bit into the corona, which is above the chromosphere, and that releases some of the corona into the solar wind, and that's called a coronal mass ejection. It's what gives us the aurora borealis if one comes towards us. But looking at the chromosphere, we're looking at the atmosphere that is just above the photosphere. Now that the clouds are clearing out, you're actually starting to see some of the really great magnetic field lines here. It's actually starting to overexpose a little bit down at the bottom. I can cut this down a little bit here, my exposure. I'm going to have to lower my actual overall exposure time because it's getting so much earlier or later in the morning. There we go. That is one sexy view. And look at these right in here, fantastic field lines. Now there are some, this actually looks like a little filament right here. If we blast out the exposure, we might actually see some prominence around the edge. Let's give that a try, see if we can see anything there. Yeah, we do. There's some prominence here. Very little. Sadly enough, it's not as dramatic today as I'd like to see, but you can see a little bit right here. This is a nice little prominence. Some of them over here. You got another one up over here as well. Just some good looking prominences. I'm going to do a quick capture of that too. And these prominences that we're looking at, it's just like I was describing. It's almost like plasma flows that come off of the chromosphere or the photosphere, and they flow through the chromosphere. They change very quickly as well. So when you're looking at you don't notice changes all that frequently. Over a period of a couple hours, you may notice some changes in sunspots if you're looking closely enough. Like sunspot groupings, they might get closer, might get a little wider. But on the chromosphere, you can see changes happen very quickly. Sometimes you can see a prominence just kind of fade off right in front of you. A lot of times when we're looking at the hydrogen alpha telescope at Frosty Drew, the chromosphere, visitors actually miss out on some of the prominences because we'll see a great view, and then the next person goes up and look and they're gone. And with that said, we're now at the time of the year where we start our solar viewing program. So starting tomorrow, Friday, we will be opening at 6:30 every Friday, showing the sun until the sun sets. So that's something to put on your calendar. Come on out and geek out with the sun, right? And it's funny, I feel like the sun isn't as popular as you'd think it would be. Whenever we say, oh yeah, we're having solar viewing, we can get a couple of people to come out. So I'm going to switch over now to the white light telescope. There we go. Now this here is the type 2 white light filter on a refractor. And the view looks very similar to what we're just looking at, but the difference you'll notice here is that there's on the sun. It looks just very consistent, kind of like Derek's view was. You will see, the wispiness. These are clouds passing in front of the sun, and this is obviously on the moon. But you don't see all of that graininess. You also will notice that when we put our gain up, there's no prominence in the view, because we're not going to see prominence with this type of filter. Now, when we're looking at the sun in white light like this, what we're looking at is actually the sun. It's all the visible light of the sun just stopped all the way down, or dimmed down to about less than 1%. And when you look at the sun in that manner, you see the photosphere. It's kind of the same thing the eclipse glasses do. Like, try to look at anything else with your eclipse glasses. You'll see nothing. The sun, you do. The hydrogen alpha telescope, instead of dimming just your brightness down, it's also taking it's isolating just the hydrogen alpha wavelengths of the sun. And that's where the chromosphere becomes visible. You can't see the photosphere at that point because it's too dim. So it's not enough light. Photosphere is not even visible. And you're only going to see the chromosphere in hydrogen alpha, which is it's a wavelength. It's right at the edge of the red wavelength before you drop into the infrared. It's about 486 nanometers, I think. And not like anyone really cares what the wavelength is. But that will... I'm crushing my case here as I sit on it. Maybe that's an indicator that I need to consider my weight.
Eat more salads.
Eat more salad, right? Less potato chips.
My kids are addicted to the veggie straws, and man, those things are not healthy.
No, I know. I know exactly what you're talking about, and I'm just like, ugh. I kind of avoided myself. All right, I'm going to try to capture some of this here.
I managed to strike a really good polar alignment.
Would you eyeball it? Nice.
I just like the parking lot's north-south slam.
Nice. I got out early enough to do a polar alignment on site, so I wouldn't have to worry about that.
Yeah.
I kind of I figured, I don't want to be fighting with it. My entire life is 10 minutes behind schedule. So I figured I'd get here really early, because I knew that if I didn't get here, it would have been perfect. So I figured I'd rather risk a cloudy day and be here on time.
Yeah, we're a little bit past where that vertical line on the sun. So
yeah,
40-something% covered, 38% covered probably.
It's interesting too, because if those who were with us when we first tuned in, like, the sun was extremely eclipsed by the moon, and the moon has moved quite dramatically out of the view. This is one of those times where you can actually observe the motion of the moon. This change in the eclipse that you're seeing is due to the moon's orbital motion around Earth. And this is the rate that the moon orbits Earth. It's not as fast as you would really think. And sometimes, I'm not noticing it too much today, but sometimes on the edge you can see indentations from different regions on the moon. Now, I don't think we're seeing it today because the moon is departing, so we're looking at the eastern side of the moon. But sometimes you get a really great view on my glasses here of what's called the Oriental Basin. It's one of the larger craters on the moon. Oh, they're on my head right here. Let me see. I'm going to take a look at our chat. I know it's kind of filling up. I blame Apple for not having a phone capable of capturing images of the sun.
Maybe that'll be on the next one.
Nice. That's great. It's funny too,
Yeah, look at that. It's moving quick now.
like
Or
the amount
it looks
of,
like it's moving quicker.
you want to switch back over to you?
Sure, we can switch over to me for a little bit.
It's funny how you get, like in 2017, we had like that crazy amount of attention on for the eclipse. But I feel like it's relatively non-existent for this eclipse. We've had
It's
very
also
little
really early in
write-ins
the
about it. And I wonder if it's because it's so early in the morning.
Yeah, could be.
Like perhaps it's easy. People they don't want to get up early. You know, they're saying, wait a minute, I gotta be up at 5 o'clock to see this thing? No.
Too early.
Derek, did you get a haircut?
I did. I have cut all the hairs, shaved the beard, and preparation for my sister's wedding this weekend. So.
Oh, that's right. You got that wedding to go to. I was gonna say, for those who remember Derek during the height of the pandemic, like he looked like someone's pet.
My coworkers. What is the name? Cornelius? Yukon Cornelius is what my coworkers sometimes call me.
I could see that. I mean, you had like hair and beard, and I knew I knew Derek was underneath it somewhere. We just weren't sure where.
Yep. That is looking pretty good. You can still see, though, we've got thin clouds just rippling across the sun. And that moon is really moving off now. When we first started, it was pretty deep cut.
Yeah, it's moving pretty quickly.
I didn't
this
manage
point
to
here,
capture image for comparison.
I mean, we're definitely like maybe about a good 5 to 6 degrees off the horizon now, if not higher.
Yeah. Did anybody set up at Frosty Drew?
No. A couple reasons. One, nobody wanted to get up on Thursday morning except for you and I and Mike. And you and I are down here, and I didn't want to leave Mike with the potential onslaught like what happened in August 2017. Yeah. But another reason, and a bigger reason, is because though we do have an excellent view of the sky at Frosty Drew, we don't have views of the horizon right down to the water like we do where you and I are now. And we'd be waiting a pretty good amount of time to actually see the eclipse. So actually, I'm surprised how clear it is today.
I think our next Messier Marathon should be at this spot. You get horizon on both directions.
Yeah, we don't have to worry about fight with the trees, right?
Yeah.
I can actually see the offshore wind farm out here today.
Really? Off Block Island?
Yeah, you can see. I can see Block Island really clear as well. Well, I guess that cold front actually came through, huh?
Yeah, apparently.
Thank goodness.
Oh yeah.
I'll get my battery warning.
Uh-oh.
So,
well,
if I end up dropping off, I could try to patch into that, but I'm probably going to kill that if I patch into it, but I can try. I'm going to give it a couple minutes. If I drop off, Derek, you're just going to carry it from there?
I can definitely show people the views, but I don't know if I'll have the depth of knowledge, and I don't
Well,
have the YouTube stream up, so I won't be able to answer questions. But I can maybe do that right now.
I'm
I'm
gonna see if I
thinking
can
about it.
boost into my laptop, my battery pack here real quick without blowing it up.
But that might also be a good spot to wrap up. Let's see, Frosty Drew.
All right, let's see what it's doing. Let's see if I just blew everything up. It says it's charging.
Hopefully not.
Am I charging?
This
Right,
might do some feedback, so I'm going to mute real quick.
Yeah, no, that's not gonna work. If I was in the parking lot, I'd be able to patch into my car's inverter. I'll can my video for now. Let's do that. That'll buy me some time.
I don't even see the live chat on our YouTube stream. What's up with that?
Yeah, I'm overloading my little inverter here.
Yeah. But we can definitely see the sun is coming out from behind the moon.
See you later. All right.
I tweaked the color balance a little bit so it looked more yellow instead of
I noticed
straight
that.
white.
I wasn't sure. What camera do you have on there, Derek?
This is the ASI 224. So it is a color camera.
Yep.
But through the white light filter, I'm not sure how much color is actually coming through. But you can change the color balance in the sliders there. So took a little blue out, which fakes it a little bit to yellow. My inverter's struggling to keep up with my laptop as well. You hear that the fan just turned on.
I have. Give me 1 second, Derek. I'll be right back.
All right. And well, we'll talk about some other eclipses. The one that's coming up in 2024 is actually going to be longer in duration of totality than the 2017 eclipse, because the moon will be closer to Earth, and it'll take a better line across the sun. I think it's closer to 4 minutes, whereas the 2017 eclipse was closer to 2 minutes of totality, and which is a little different than if you think about a lunar eclipse, if you've seen one of those where the Earth moves in front of the moon and blocks the light from the sun to the moon, and it usually happens during a full moon. Those are quite a bit longer because the shadow of Earth is much larger than the disk of the moon, so the moon has to travel through that disk. And it's about, at the distance of the moon, it's about twice the diameter of the moon. We might have lost Scott. Lost a box. And it's kind of fascinating to think about how this alignment happens. And if you were lucky enough to see the eclipse, the lunar eclipse that preceded this solar eclipse by 2 weeks, you would have had to have been on the west coast of the U.S., Hawaii, or in the Pacific area, and that was something that side of the world got to see for that event. And there was a lunar eclipse in 2019 January, and it just so happened that the other side of the world got to see the solar eclipse that went with it. And I'm not sure if that's a typical pattern or if that just happens to be, true for those two events that I'm thinking about. It might be worth looking into to see if that's, if that holds true for a lot of eclipse events where the solar and lunar eclipse are seen by opposite sides of the planet. Let's see. Yeah, we're still seeing the moon move out of the frame there. Starting to look a little bit more like Pac-Man. And we're pretty lucky to live at the time that we do, because in a few hundred, a few thousand, tens of thousands of years, the moon will have moved farther away from Earth, and solar eclipses that block the entire sun will no longer be possible because the moon never gets close enough. It moves away from us a couple inches a year, and over time that will develop to the point where the moon is always smaller in angular diameter than the sun is. And then we also are lucky because in the way that the moon and the sun are very close in size, when we do have a total eclipse of the sun by the moon, that edge of the moon as it covers the sun is closely, aligned with the radius of the sun, so we get a really nice dramatic event there that sometimes looks like sparkling diamonds in the sky when that happens. And that's because of those craters along the edge of the moon that Scott was talking about earlier that we can sometimes see during an eclipse, because those features are, just like mountain ranges on Earth, they stick up, or they're valleys, and you can see that sometimes in the profile or the silhouette of the moon that's basically cast against the background of the sun. I'm surprised those clouds are still there. You can barely see them here from the ground. Yeah, just a little bit of a ripple for those clouds going across there. Let's see if Scott texts me to tell me that he's out. Nope. So maybe he's still trying to figure it out. But yeah, just if you're still with us, check out the end of the eclipse here. I'm going to try to get the live chat to load so that if there are any questions, I can answer those. I'm going to mute for a minute while I click around and do that. All right. So that worked. I had to reload my browser, or that tab. I think the eclipse is over at around 6:30, which is about an hour after the peak of where we had the maximum coverage. So the whole event is about 2 hours from start to finish. And it of course started before the sun actually rose, and we saw the sunrise around, I think, 5:12, 5:15, and that maximum eclipse was around 5:30. I think Scott called it at exactly 5:32. And that's based on data that you can find about the eclipse on NASA's website. They have a really cool page that's all about the eclipses for the next like 100 years, and they give you a map of what regions of the world are going to experience the eclipse, and that's kind of what we use as a tool for figuring out which ones we can see and which ones we're going to have to get our friends to take pictures for us. All right, let's go back over here and follow this down. We're not quite perfectly aligned, but I think we'll survive long enough to see the eclipse through. Make sure my telescope is still tracking. That's always always a question. If Jupiter was where Venus was, Earth would not be where it is today, because the gravitational effects of Jupiter would disrupt any possibility of a planet existing where Earth does. And there's a theory that that's why we in fact have an asteroid belt instead of a planet at that spot in the solar system, is that Jupiter disrupted the formation of that planet and basically just didn't allow it to happen. Yes, and you would be able to see a perceptible object against the sun. Whether or not you would see a perceptible decrease in light or not, I doubt. If you ever experience a total eclipse, which I highly recommend, it is a crazy experience. The difference between 95% of the sun being blocked and 100% of the sun being blocked, just as clear as it was. It's not like a bright sunny day, but it's a cloudy day. And when you block 100% of the sun, it's like early twilight or something late in the evening. And in fact, all of the night dwellers start becoming active. So you hear crickets, and you hear all kinds of creatures that are typically active only in the twilight, which is a fascinating phenomenon to see in the mid-afternoon for just a few minutes while the sun is blocked by the sun, or while the sun is blocked by the moon. Excuse me, I got up at 3 o'clock this morning. Typing and talking at the same time is pretty hard, so I am just you're a dual star system. In a similar fashion, the gravitational effects of the dual stars is really hard to predict, and I don't know if we've discovered any binary star systems that have planets. Now, that's just my personal knowledge. That doesn't mean that we haven't discovered them. It just means I don't remember reading about any. And that's similar to if we had multiple suns. You kind of have to figure out, well, is there a stable orbit around those suns that allows a planet to exist in a given orbit for long enough for life to become dominant on that planet in a way that we think of our planet being populated by life. I don't know. It's a good question, and it would certainly be interesting to have two suns if it's similar to where you would have two suns setting at the same time, or if they would be on opposite sides of the planet, or something like that. It's an interesting thought experiment. The one that I've always wondered is if you had two moons that are closer in size to our moon, and what would that do for a planet? Because the moon drives tides, which are an essential part of our planet's cycle and its environment. All right, we are very close to losing the sun here. I'm gonna take another picture. We've got a big cloud actually coming in, and so that might kill us. We'll see how close that is before we can't see the binoculars, but definitely see a pretty large cloud rolling in. So that's excellent. I'll have to check that channel out and see if I can find it. But New England is famous for its clouds. That's for sure. We fight the clouds all the time on our Friday night events, and sometimes the forecast will be cloudy and it'll be one of the best nights we have, and sometimes it'll be forecast for clear and we get completely clouded out or fogged out or misted out. It's a fascinating thing, our New England climate here. All right, let's see. That's looking good. Yeah, it's drifting towards the bottom of the frame, but we'll probably see the moon leave the frame before we see the sun leave our frame. But you can see actually right now, talking about is starting to move across the sun. That's that darkening that we're seeing starting at the bottom and moving up. So we'll see how long this goes, and if we lose the sun, we'll probably cut the stream there. I actually don't have the ability to cut the stream, so I'll have to see if Scott can do that. But yeah, it's always good. Yeah, it's pretty cool watching that cloud coming across the sun. And you can see the detail on the cloud there. Actually looks a little bit like Jupiter. Oh, that's fascinating. All right, let me see if I can play with the exposure a little bit and you guys can see what I'm seeing. The human eye is a really fascinating optical instrument, and it just does so much more than you think when it's processing or capturing light. And the dynamic range is phenomenal compared to a camera. And it's really something. Like when you look at a planet through a telescope, you see all kinds of awesome detail, and you can see all these little features, and you take a picture of it and it's just this blob. Yeah, look at that. That's crazy. That's just the front edge of this cloud. There's a much thicker part of the cloud coming. So I'm going to watch that, and then I think that'll be the end of the stream. Almost we got the whole thing with the moon coming out of the edge there, but it's probably going to get covered by this cloud before we see the moon completely drop off the lower edge there. Yep, the observatory is open Fridays. We post on Twitter, and actually I think we just post on Facebook for the event status, and then sometimes we post on Twitter if we close up early. But I think we've been running 8:30 to 10:30 has been our typical event lately. That might be changing as the sunset gets later, and we might go a little bit longer as we start to see larger crowds. But it should be pretty typical, 9 to 11:30 or something like that. But check out our Facebook page, and if you go to frostydrew.org, you can sign up for our weekly email that also has event details that will help you understand if our events are happening or not. And usually, unless it's actively raining, we'll be there because we've been doing like telescope tours and that type of thing on nights that are not great. You can see those clouds are getting a little denser. Oh man, yeah, we're not looking good. Not looking great. Let's see, can we salvage anything here? Just a little bit. So we'll ride that out and see how things go. But you can really see that bottom corner, that bottom edge, bottom left edge. The moon is almost gone. Oh man, my camera can't even do this. All right. Yeah, still, I'll move the mouse out of the way so you guys don't have to tolerate that. We've probably got about 5-10 minutes left of the eclipse here, and the clouds are making their presence known. All right, let's see. How's my battery doing? All right, we're gonna go for our last field trip here. Sorry for the Velcro noises. High-tech camera here. So you can see we've got a big cloud moving in front of the sun, and the sun is quite high compared to this morning. Now we're about an hour and a half after sunrise. Ow. Oh, look at the sun. It hurts. See if I can line this up. I think that's going to wrap up our event today. Thanks for joining us, and I'll let it go until I can't see the sun anymore, but I'm going to start dragging my gear back to the car and going back to bed. I didn't bring my table because I was thinking I would use the hood of my car, but it's on the road because the parking lot's closed. All right, let's see. Oh yeah, we still got a view. just a little bit there, that little sliver down there in the corner. The round object, and I'm saying corner, but you know what I mean. On that edge. There's about less than 5 minutes left of the eclipse, so we'll let it go to the end here. Looks like it's going to poke through the clouds long enough for us. I'm going to spy on Scott. Yeah, he's breaking his gear down too, so he must have lost power. That is the trouble with astronomy in the field, especially when you're trying to do a live stream, is finding power. Here we go. This is going to be the last few minutes here. I think there's a little sliver left there on that edge. Well, I think it's over at 6:31 if I remember the time sheet. All right. Yeah. The clouds are going to end it for us too. Wow. That's crazy. Well, I'm going to pack up. The live stream is going to go until we actually kill it, which I can't do. And thank you for joining us. And have a great one. And hopefully we'll see you guys at a Friday night at Frosty Drew, or maybe one of the Saturdays that we're doing this year for the Milky Way event, which will focus on the Milky Way. And those are on Saturdays, but they're not every day. So definitely check out our Facebook page and our website, frostydrew.org. Thank you, and everybody have a great morning and a wonderful Thursday.